Well, you saw me make this 24-volt battery before I had the BMSs, and I showed that in a quick video. Try to do a little more in-depth. Here's another one that I'm making. This is a 24-volt 30 amp hour battery, and I reclaimed all of these cells out of a motorized window shade batteries that I bought off of battery hookup, I do believe. I'll show you those here in a minute. And some of them I've had to re-sleeve, some of them I've had to grind a little rust off. That one could use a smidge more. And this one here, probably grind these tabs off a little on this one. All these weld points. So I 3D printed these in 3 different colors just to be fancy. So I'll walk you through how I put this whole thing together. These are the batteries I buy. Yeah, they're from a motorized window shade. I'd tell you what, about 85–90% of them are still good. Anything with a high resistance I'd chuck out. But I'm saving all of these leads. I got a butt ton of them. Message me if you want some. We'll work something out. I hate to throw away all that good wire in these connectors. But so I'll strip the case off, and then you get this. So I'll cut the leads off and throw away the BMS, snip everything out. Then I put each cell into my battery charger, test them to see which ones are good, and run them up to full charge before I use them. And then I can't do this one-handed, but then I tap this baby down, and then we get to welding. I'll have to do this off camera because I need 2 hands. There we go. Everything's in, and once I run the nickel strips around here, it'll lock everything in, and then I'll also wrap it with tape just to hold everything nice and tight. I think this time I'm going to draw the power off of the center of the battery instead of the ends like I've been doing. I don't know why, but I'm going to run the nickel strips, and then I'm going to run a second layer just to cover the extra amperage toward the center of each of these. So what we have here is 7S to give me 24 volts, and then I got 12P to give me 30 amps. Each one of these is roughly between 2.5 and 3 amp hours still. I chuck out any battery that's not good. Oh, and I forgot to tell you, so these things, after taxes and shipping and everything, they wind up costing me about $1 a cell, and like 80 some cents a cell. And if I, roughly compensate for the ones that I chuck out, we're talking about $1 a cell. So there's a bunch of them, and we'll take those to the Home Depot and put them in the recycling bin. Yeah, here we go. I got my battery welder out, my Puddles Pity Party Turbo Charging Sticker. Puddles Pity Party is one of my favorite singers. He's awesome. He's out of Atlanta. But this is about this battery. So I've gone and I've cut a bunch of nickel strips. So I cut 7 long ones and 7 short ones. The 7 long ones will go on the positive terminals and then stick out a little bit so that I can tie in the BMS. And then the short ones will go across the negative. And then I cut a bunch of 1-inch to strap across to make the series connections. So these are for the parallel connections, and these are for the series connections. All right, so these are my parallels, and then a little bit sticking out for the BMS leads, and I can trim that down. And then this is the negative parallel. I'll go all the way across. And then this is my series connection. This is a 30 amp battery, a 30 amp hour battery, and I don't know what kind of draw I'm going to do on it. So I'm going to put a parallel connection on each and every one of these to make sure there's plenty of nickel so that the power can flow without any resistance or without heating up the nickel strips. There we go. That's my first round. What I didn't show you here is I've marked the batteries. So this is going to be my main negative, and then positive 1, positive 2, positive 3, positive 4, 5, 6, positive 7. So this will be the main positive out, number 7. So when I wire up the BMS, this will be the black wire, this will be the first red wire, this will be the second red wire, and on and on and on. And so what I will do is I will nip this down so that it's level with this spacer. That way we're not accidentally digging in through the blue stuff here, and that would create an instant short and start a big huge fire, and we don't want that. So the next thing I'm going to do, and I don't know if this is required or not, but for me, I'm going to put a line of Kapton tape across this one so that while I'm soldering these, if I drop something, or there's no chance for any kind of short. So I'm going to insulate these and then start working on these, and insulate these and then start working on the next ones, and so on and so forth. And then when that's done, I'm going to flip the battery over and do the other side. All right, so I've flipped the battery around this way so I can work on these next 3 rows. And this is 0.2 by 10 nickel strip, 99% pure nickel, and the carrying amperage is 11 amps, 14 amp max. So what I've done on the parallel lines is I laid a strip down to the parallel all the way down. Then I did the series crosses, and then I went and I laid another parallel line down on top, so that now we've got 22 amp carrying capacity or 28 amp max carrying capacity. And I can't imagine running 28 amps through this battery, but we've got it to where it's safe enough to do, and I don't have to worry about overheating any wires at all. So we're going to do that for the rest of this side, and then I'm going to flip it over. All right, so you see here, this is the foundation layer for the parallel, and then these are all the series straps going across, and then this is the second layer for the parallel that I put on here, and that, again, that's the tab for the battery management system leads. We'll have one of those on every positive. So we'll put one more here, then we'll put a double layer here. This is going to be the main positive out, This is here number 7, positive. So that'll be the main positive out. And then we'll put the BMS probably around here on the other side. That's what I did on the last one. And maybe on this one I'll take a couple positive leads off and then double them up, and a couple negative leads off and double them up. Okay, this side is done, and I got Kapton tape on everything so I don't accidentally short out anywhere, especially having nickel strips around and, you know, pieces cut off in case I don't get them all picked up. We don't want anything stray and metal causing any problems. I don't know who, but I heard of a guy one time was trying to measure his battery pack and actually laid his steel ruler right on top of the battery. And thank God for cat-like reflexes. But I won't name any names. I can't imagine what kind of fool would have done that. Not enough coffee. And now we're flipped over. And you see -1. This will be my main negative line. And positive 1, 2, 3, 4, 5, 6, 7. That down there is going to be my main positive line. And then I'll run all of my BMS wires here and probably mount the BMS right here or here. I don't know. We'll see what it looks like. On the other one, I put it here. Again, these are all used cells, so some of them I had to get a little rust off, hit it with the Dremel and pumice stone. Don't want to cut too deep because once I go welding it, you know, we don't want to punch through. Oh, that one's still got a piece of nickel I'm going to have to pull off of there. All right, I'll show you what this is like when this is done. Got a small patch job here. While I was putting the nickel, this is the first side that I did up, and then I flipped it over, and as I was doing this row, when I pressed down, apparently, and this is one of the downsides of using used batteries. Apparently the insulation around the positive tab had been compromised and I didn't notice. And when I pushed down and started welding the tabs on the other side, something shorted here. And this battery started getting real hot real fast. I always keep a bucket of water in my utility tub on the other side of the basement here. And so I was able to cut this baby out and grab it with a pair of pliers and dunk it in the water and let it fizzle out, and then replace the battery. I don't want to do it, but I'm prepared to avoid a fire of dunking this whole thing in the water and losing all these cells. That's better than lighting my basement on fire. Yeah, these lithium, I'm sure you've seen 100 videos about lithium battery fires. So I cut it out. I had to replace a couple of these cell holders because they got hot and started to melt. And I put another cell in and then tacked her up. So instead of 2 layers, we got 3 layers here because I'm always going to go more than less. And we got a bad weld there. If it's not full contact, it'll pop right through the nickel. This is on the negative side, so I'm not worried at all about any kind of short. So, disaster averted. Now we're on this side. I've got half the battery done. On this side, this is taped off for safety. This is going to be my -1. This is my main negative here. So I got layer 1 down, doing the series straps, and then layer 2, and then 2 layers here, and then we can start with the BMS. So while I'm welding these together, I'm constantly monitoring temperature. You know, the weld points get hot, but if it doesn't cool down immediately, then I know there's a problem. Also, with this, and again, if you watch any of the other videos, you know, this is a CCE. I got this off of Amazon. The cables do get warm. The where are we? This is the capacitor voltage. You know, if I'm going too fast, that capacitor voltage will start dropping anything below 4.7 volts, and it starts compromising the welds. So you can't go too fast. You got to let things cool down. You got to let things charge back up, and that gives me time to feel out what's going on, and you know, take my time putting these cross tabs in. If I put too many cross tabs in, I'm going to hit something with the heel of my hand or the wire, and it's going to go somewhere I don't want it to and cause all kind of ridiculousness. Well, this is good enough for we can give her a try, test our voltages. So I got the negative clamped down with a magnet here. We got 4, 8, 12, we got 16, number 5 gives us 20, number 6 24.9, and number 7 is 29.12, 3, 1, 2. So that's our 24 volt battery. Alrighty. Let's keep moving on. Okay, so we got her all done up. Double rows on each. We check the voltage. It's all good. So now I start wiring the BMS. I'm going to put the BMS here. Here's my leads. So let's start with number 7. And if you notice, I went and I put a dot of solder on each one of these tabs first. So now I'll do 7, 6, 5, 4, 3, 2, 1, and then negative tab plus main negative out. All right, I got my phone propped up. Maybe you can see what I'm doing here. So this is a nickel strip, and I am going to solder my BMS battery lead into the nickel strip, or I'm going to attempt to do that. These are all nice and hot. Melt her on down there. A little more solder. Ooh, that's warm on the fingers. Okay, so that's soldered in. Now we're gonna... So this is the BMS. This is the power out. This is the battery in. That's probably all going to be upside down for you, isn't it? Sorry about that. All right. There's my phone holding jig. So we got the battery. I got the BMS leads all nice and pretty. I got the negative lead over here. And I've got my leads here. I'm going to put the BMS here. I'm going to glue her down there when I'm ready to do that. So what I need to do is attach the negative BMS here. So my plan is, now that I've got this soldered in here, I'm going to weld this sucker down and then fold it over and give a double weld so we have it nice and thick, and that'll be my negative battery lead. Alright, so I got her tacked down real good there, and then I soldered the living daylights out of it there. Let's see if we can get a better image of it. So that's good and solid. That's a really good connection. Now I'll mount the BMS and then work on my positive lead. Alright, get the old heat shrink tube out here. And I have attached the positive, and I nailed her down a whole bunch of times. Did the same thing where I soldered it into the nickel strip and then tack welded it onto the positive, and then the negative off of the BMS. There's the BMS. So this is the negative line, and it ends there. So I did a butt solder on that, and then I put 2 layers of heat shrink tube on that. And so now I'm gonna put a XP90 connector on this end, and we should be done. Let's get the old multimeter out and see what she looks like. Close this up, and then I'm going to plug this in. I really need to get some kind of camera mount. Okay, so that's in. And oh, and here's my thermal probe. I got her stuck in there and taped down real good so we can monitor the temp. Alright, so BMS is plugged in, and meter is on. And let's see if I can do this one-handed without shorting out the battery. I don't think so. What can I do? I got an alligator clip here. Okay, got an alligator clip on the negative lead. Going to the BMS. BMS is plugged in. I got 0 volts. I'm going to go over here to the positive. 29 volts. And grab onto the positive. 29 volts. Beautiful. What do we got? 12, 16, 20, 24, 29. And these are all taped down, but I tested them before. So everything's good. I'm going to put a little extra insulation here so that this positive terminal never shorts out on the negative of this battery. I'll put it underneath this lead, as a matter of fact. And I've got that insulation from the batteries when I disassembled them. They had some good thick insulation, so I can put some of that in there. And like I said, then we'll put an XT90 on here, and we'll have ourselves a 24 volt 30 amp battery. Finish taping her together. Use the old fiber tape again. Hold this baby down. I love this stuff, but every time I use it, I gotta hit the old scissors with some alcohol, get all that goop off of there. Okay, there's the second one. There's the first one. The wiring's a little sloppier in the first one. I've got her connected to the old battery tester, and we'll run a capacity test on it and charge it back up. Run a second capacity test. One thing that I just realized, this one has an XP60 and this one has an XP90. So I'm going to leave it like that until I decide what I'm going to do with these, and then probably tighten this one up a little more, and then change whichever battery connector needs to be changed for whatever application I'm going to use these on. Because at this point, I don't know what I'm going to do with these. I might use them, oh, you can't see it, might use them as a backup for my computer BMS backup underneath there. Or I might just put them out in the garage and part of my solar project. We'll see. But there we go, the second 24 volt 30 amp battery. Thanks for watching.